Hi everybody, Jeff Simon here for SocialFlight with another cool building stage on our Titan T-51D Mustang. Now, if you followed our build for a while, you know that we've been struggling a little bit with the resistance and feedback forces from the autopilot that we had installed here. And we really want to get everything right on this build before we do the finished closeout. We've got the skins fitted, we've got the top, everything, windshields ready to go. But before all this gets closed out, we've got to get everything right so I don't have to go upside down on my head and try to fix a problem later or deal with something that's really inaccessible. And the challenge that we've been having is actually, so we've got the Bendix King Aerocruise 100, the True Track autopilot, and the challenge is that it uses these stepper motors as their trim servos, or their main servos, excuse me, for both roll and pitch in that. Now for a larger aircraft, for Cessna, Piper, other GA aircraft, absolutely fine. But for a light aerobatic aircraft like our Mustang, we really want to have smooth controls that just float and don't actually have resistance that's built in from the autopilot. And the problem with a stepper motor, which we've been struggling to solve, is that it's always engaged. And so when you go and you try to turn this, it's very hard to turn this with your fingers. And of course you've got more leverage when you're using the control arm and then we're using a control stick or your yoke. But ultimately you still feel that drag every time you move the stick or the yoke. And that meant that in our case, for example, even on the ground, you put the stick into a position and it's there. You move it, it just stays wherever you put it. It's not light and floating the way that we really want this Mustang to be. So we tried a few things, we measured it, you saw the previous videos, but at the end of the day, we actually ended up deciding to make a switch, and that is an upgrade to the Trio autopilot from Trio Avionics. And the key to the change for us, even though there's tons of other features that I'll explain to you, the key to us is this. It's their intelligent gold standard servo that you see right here. And I mean, right off the bat, if I go, I can just spin this thing. It takes no force at all and it just moves. And the reason is that this doesn't use a stepper motor. This gold standard servo uses a regular linear motor and a clutch. And that means when it's not engaged, it is not part of the system. You don't have to worry about it giving you all this feedback. And then we can just have these smooth control surfaces that we're spending all this time putting you know, so much time into making sure that everything with its built-in rods and things has no slop and just feels wonderful to move the controls back and forth. Now, the reason this is actually called an intelligent servo by Trio is that it's actually always connected to the autopilot electronically, and it's monitoring with a microprocessor everything that it's doing. It's actually looking at the degree movement of the servo arm, seeing if it's within limits, letting you know what forces are against it, because it actually gives feedback that then allows the autopilot to do trim, and we'll talk about that in a little bit. But there's tons of features in auto-correcting that goes on, and the nice part for us is that the form factor is pretty much the same. It's going to be able to fit in the exact same location. It's going to be a quick drop-in change that we actually do, and of course we're going to go and do the control head. So let's get to work. We're going to go to the instrument panel and I'll tell you more about how we're going to make this change to the Trio Pro Pilot on our Titan T-51D Mustang. All right, this is the control head and the brain of the Trio Pro Pilot autopilot. And there is a ton packed into this. So I want to talk about some of the features before we get to our install on the Mustang. First of all, I have to say it is amazing that they were able to fit so much all into this one control head. It's a form factor. It's available in two different form factors. There's a rectangular form factor that you can use if it's going like in your radio stack or something like that. And then there's this one that goes in a standard instrument hole. And it's got a lot in here, but it does some amazing things. And most of them are around safety, because when we think about using an autopilot, then the basics, they should all be there. You should be able to climb at a given rate. You should be able to go and fly a course and do things like that. It's all pretty standard in terms of like holding an airspeed or holding a climb rate or holding an altitude and then tracking a course. But this autopilot does quite a bit more, and again, it's all around safety. So when we think about it, there's a few things. Well, one of the biggest things that this does is a feature that I'm not aware anybody else has, and it's this automatic 180-degree turn. Now, this, like many autopilots, already has an automatic level function. You push one button, in our case it's right on our control stick, and it's automatically going to wings level and hold altitude at that. But in many cases, especially for VFR pilots, if you are, or if you're just trying to stay VFR, even if you're an IFR pilot, you may accidentally get yourself into IMC. And the question is, what do you do in that situation other than just hold the wings level? Well, Trio's answered that with this 180-degree turn feature. All you do is one of these two buttons at the top. You've got the HNAV and the VNAV for horizontal or vertical. And if you take this left button and you hold it for 3 seconds at any time, it will just level the wings, turn you 180 degrees to the left, and reverse course for you. Your autopilot do it completely for you. The right hand button of VNAV, hold that for 3 seconds, exactly the same thing to the right. So you decide where you want to turn, how you want to make it, but you just hold it, the autopilot will take over while you recover. I'm telling you, for a lot of either low time pilots or VFR pilots, this is a feature I would want in any aircraft. Now, in addition to that, there's a bunch of other things. Auto trim, for example, is included. We talked about the intelligent servo. Well, that is measuring what kind of force is required. It can actually talk to the computer and then go back out to your trim system if you have electric trim, and command the trim system to relieve that pressure. It'll automatically trim itself. This is something that it doesn't even exist on a lot of larger autopilots for larger aircraft. In many cases, that's an option. So that's a great feature in order to have in it. It has built-in fuel management. If you happen to have a fuel transducer, this can actually be part of your fuel computer system and do some of that. You can do airspeed limits. That'll help you in case of kind of emergency situations to say, we know that we can climb at up to 2,000 feet per minute, but at the same time, we don't want to get too slow. And so your autopilot can know what your boundaries are, what your limits are going to be on what is too fast, what is too slow, and the autopilot will not exceed that as well. There is actually accelerometer that is inside the pitch control, the actual box, that will of the servos, that'll let you know what's happening in terms of those forces, and that helps you with that trim. And this actually helps you with the other types of things that happen with, again, airspeed limits, etc. And then a couple other things that I just like as a pilot, and that is this thing does great intercepts, meaning you can actually tell it how you want to intercept courses, and it will do the intercept and then track it. If you're an IFR pilot like I am, then this matters a lot because you want to pick up an airway. This will take you to it, grab the airway, head that way if it's a direct course, instead of just from where you are now, because that's part of IFR flying in many cases. So that's really important. And then additionally, if you fly on airways for safety, you can offset yourself from that center line. That's also built in to the Trio Pro Pilot. You can just say, this is the kind of offset I want. What I mean by an offset is, you know, in this day of so much being automated, if you fly to an intersection or VOR and then to another intersection or VOR, you're on exactly the same point in exactly the same line as everyone else on that airway. And for safety, you may want to put yourself a little bit off that center line. So if there's some issue, especially when you're climbing through different altitudes all to the same, you are not going to be on that exact course as someone else. And so again, safety, safety, safety. And big thanks to Jeff Odom over at Trio for explaining all of this, educating us, and bringing us up to speed. That really helped us make the switch to this autopilot. So let's now go to the installation. All right, the ProPilot control head is going to go right here in the instrument panel. One of the nice things about this design that's really working out well for us is that we set this up so that the entire instrument panel can pull forward into the cockpit. We actually have a piece of wood that will be part of our permanent part of our build that we actually can put into the aircraft and use as a shelf anytime we want, and then the instrument panel can just pull forward, giving us easy access to the back of it. And then if we need to remove instruments or do any rewiring, it's very, very simple. So it's going to get located here. Now, one of the other things is that if we look at this, the way that the Trio ProPilot comes is it comes with this harness, and there's only a single connector, one single D-sub connector, which is great because it just simplifies everything. And then they give you in the wiring harness two bundles, one that goes out to your elevator servo and one that goes out to your aileron servo. So pitch and roll, you just roll all these out, and then you're left with this last set of wires. Now for us, it's going to be an easy swap because these additional wires are pretty straightforward. Certainly going to be power and ground, but in addition to that, we already have the same inputs as we had in our previous autopilot. And so that's going to be an RS-232 data input, a 429 input, which has A and B. That's all for data. This is where we're getting our GPS, our fuel information, anything else that we're feeding in. This gives us all the data that we need from our navigation system through 429 and 232. So boom, those three wires, we just pull the pins out of the original harness, put them right into the right place on this one. Then you're left with a few other things. One is going to be your wings level control, which is that single wire input, that switch that goes to our control stick. Again, pull the pin out of that, move that over. There's another one for control wheel steering, do the same thing with that. And at that point, we've pretty much nailed everything that we need to, except there's one other difference between the Trio and pretty much every other autopilot. And again, that goes back to safety. Jeff Odom explained to us from over there that they want to make sure that there are no single points of failure in the system that even get to your navigation. So in this case, we get our navigation data that's coming through to it straight through what's coming through the Aspen. And they say, well, what if your primary fails? Well, they have it built in that they always want you to have a switch that allows you to go directly and only to your navigation system also. So it's actually got a switch that switches between what our source is going to be, again, for safety about where it's getting that 429 navigation data, because it in itself already is going to be able to know how to hold a course and how to hold you level if you lost your primary display. So again, that's really important because you're going to use your primary display unless you lose it, and then you can switch across and get something straight from your nav system. And this brings us to one other thing that I recommend for everybody, which made this change and is making this change so straightforward and so easy. And that is our Approach Fast Stack system. You've seen in previous videos that we use Approach Fast Stack. That's a hub and special cables that just plug and play to your autopilot, to your radios, your navigation system, your audio panel, everything. Plug and play. And so when it came to how do we put this switch in that Trio allows us to have, well, we just gave a quick call over to Approach Fast Stack. And it turns out all they had to do was send us one cable. We swapped out from the other one that we had in before, and everything just works. They included the switch. It's really straightforward. There was no wiring we had to do ourselves. It was really straightforward. And that's because that Approach Fast Stack system uses a configuration that is all in one plug. So if you change out your panel, once you've gone with that, I'm telling you, it is so easy. I recommend this for every certified aircraft, every experimental aircraft, because it just makes behind the panel simple. And then when you go to change, upgrade, or change decisions, it's all straightforward. Just one phone call, doesn't cost much, and you're all set through Approach Fast Stack. So I am going to do this wiring. I'm going to make good on what I said for how both the autopilot control head and the servo were easy to install, and I'll show you the final product. All right, now that the Trio ProPilot control head is mounted in the panel, we've got the wiring harness all set here. The last thing we need to do is hook up the pitot and static lines. All these autopilots require pitot and static. That's how it measures your altitude to hold altitude. That measures your airspeed if you want to hold airspeed, vertical speed, that kind of thing. It's all here, and the last thing we need to do is make those connections. Now, it's nice that we already have these two lines going into our uAvionix AV20 here, and we use this quick disconnect system. I absolutely love this. It's a really, really simple way to be able to manage your pitot and static system, and it tends to be extremely reliable, very leak-free. And all we need to do in this case is go and cut into these lines, and you can either use a T-fitting, but in this case I'm going to use this run-on fitting. It has one going in one and two coming in out the other side. That makes it a little easier for us to have independent lines that come down there, don't have to be at a 90-degree angle, and then can fit in there. Now, the last piece of the puzzle is that as it goes into the unit, it's designed for a 1/4-inch Tygon. We may use Tygon in there right now temporarily. We're going to use this 1/4-inch rubber hose. What's nice is this will slide right over the 1/4-inch quick disconnect line. So it's a perfect blend of systems. You can zip tie them together. They'll be leak-free. They really hold very, very well. And then we'll be all set. So I'm going to get this, put this pack away, and then we'll go back there and work on the servo. All right, well, I ended up going with both a T-fitting and a run-on fitting for this. And you can just see it came out really, really clean. As I said, I really like using this system. It's very, very easy to use. And now the last step here that needs to be done, just need to take the plug, get that hooked up into place. A little awkward from where I'm reaching here. And that's it. Now the instrument panel is ready to go. It's got everything that it needs, all its data lines, power, etc. It's all ready to go. And now time to go to the pitch servo, where we're going to see that great benefit of not having all that drag. The last step is installation of the push rod on the control arm here. And so I'm going to attach that first to the bell crank. And I made this rod out of 3/8-inch aluminum. Very, very simple, just 3/8-inch aluminum rod that I then went and drilled and tapped in the end. The most important thing when you're working on a servo like this and setting the arm is you really want to make sure you're nowhere near being over center. Over center means that this gets down to the point that it's very hard to actually get leverage, and over center would be if you go to the point that you could lock it up and actually cause yourself a jam in the control system, because pushing could just as easily go the other direction, down instead of up. We're nowhere near that with this right now. And as a matter of fact, just to check it out, I'm going to tighten it up right now. So let's put this in. Tighten this up. There we go. The rod is free to move, which is great. Tighten that up a little bit. I'll tighten these later when I'm absolutely positively sure we're at exactly where I want it to be. But right now, it looks like it's in really good shape. And That's one position. That's full up. That's full down. So it actually looks pretty good. And that's it. Now we can go up to the control head. All right, so moment of truth for our Trio ProPilot Autopilot. We've got everything all set up here, and it's time to power it on. Coming to life, elevation set. We don't have a GPS signal right now coming through from the Avidyne and the Aspen, but because we're inside, we do have a GPS repeater that I'm going to set up so that I can do a little bit more configuration. But it is here and it's alive, and I can turn on even the VNAV mode, and I can see already that it's doing controlling of the stick. And it's working in exactly the right directions. There's a ton of configuration to be done, which is pretty straightforward and very well documented in the Trio ProPilot manual. But I can already see that everything here is all set. And what else is really cool is the way that it integrates with the Aspen. And so I actually can control things like my heading right here from the Aspen. I go and I change my heading, and then boom, it shows up as my selection. That's going to be fantastic, because in addition to just going and flying courses that are set up through the GPS, I can actually use this when I'm doing a heading for intercepts or things like that that I'm issued from ATC, and just keep focused on my primary display, and the autopilot will go and just follow along with it. So that integration is another great bonus. And the stick, if I turn the VNAV mode off, is silky smooth. It's just none of the issues that we were fighting against before. Very smooth. Everything's set up here, and there's just a ton of features to dive into and get configured. The installation went really well. Special thanks to Jeff Odom and the team over at Trio Avionics. Very happy with everything here. And so yeah, almost everything that I can think of in our panel and in all of our electrical system is now set. So it's we're getting down to the wire here of wrapping all of this up and then getting it here out of the house. For SocialFlight, I'm Jeff Simon. Be sure to check out socialflight.com and the free apps for Apple and Android devices. We have tens of thousands of aviation events and destinations. The Fly to Win Challenge, where you can win prizes. There's just a ton going on. And every Tuesday evening, SocialFlight Live. You just go to socialflightlive.com. You can register. We have some amazing guests. There's just a ton going on, and we are here just to support you and general aviation. And so with that, I wish you all blue skies.